Alright, so in this video, we're going to be doing some practice with the root test. So we want to determine if the series converges or diverges using the root test, and we have this series up on the board here. The sum from n equals 1 to infinity of n over 2n plus 1 raised to the n power. So if we use the root test here, we take the limit as n approaches infinity of the nth root of the absolute value of a sub n. A sub n is this n over 2n plus 1 raised to the nth power. We can get rid of those absolute value signs because everything in here is positive anyway. Okay, so if we're raising it to the nth power and we're taking the nth root, those cancel out. And we're left with the limit as n approaches infinity of n over 2n plus 1. Alright, simple as that. Now, you can divide everything by n here, possibly use L'Hopital if that's what you like better, and you end up getting 1/2. Okay, 1/2 is less than 1, so this is absolutely convergent, and therefore convergent by the root test. For our next series here, we have the sum from n equals 2 to infinity of -1 to the n over natural log of n to the n. Now, this can be rewritten as the sum from n equals 2 to infinity of -1 over natural log of n all to the n power. So it becomes obvious we're using the root test here. Now, we take the limit as n approaches infinity of the square root, the nth root, I always mess that up, of the absolute value of -1 over natural log of n raised to the nth power. Okay? When you end up raising this, when you take the absolute value of this, you just end up with 1 over natural log of n, okay? Now, you're also raising this to the nth power and you're taking the nth root. Those go away as they did in the last problem. So we end up with the limit as n approaches infinity of 1 over the natural log of n. And of course you can see that that is going to be equal to 0, okay? Because as n approaches infinity, you get an infinitely large denominator. Your limit goes to 0. And you get, so 0 is less than 1. So again, this is absolutely convergent and therefore convergent by the root test. Lastly, we have the sum from n equals 1 to infinity of 2 to the n rad n, the nth root of n plus 1 raised to the nth power. That's a mouthful. So you could probably just use the test for divergence here, honestly, and prove that this is not, the limit's not equal to 0, but we're using the root test here, okay? So we got to use the root test to figure out that this is divergent. Take the limit as n approaches infinity. The nth root of the absolute value, we actually don't even need our absolute value here because this is all positive, so I can just get that out of here. This is of the nth root of n plus 1 raised to the n. Okay, the n cancels out with the nth root, so we get the limit as n approaches infinity of 2 the nth root of n plus 1. Now, looking at this limit here, you see that you have the nth root of n, and honestly, you probably need a calculator for that. Okay. When you do plug that into a calculator, like the second root or the square root of 2 and the third root of 3, the fourth root of 4, you see that it is actually increasing slowly but surely. So this limit is actually going to go to infinity. Okay, and that means that this series right here diverges by the root test. And that is going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the root test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.